Imagine you're watching your favorite animation or playing a video game. Have you ever wondered how the characters move so smoothly or how objects follow real-life physics? Behind all that magic is calculus. Calculus is everywhere, even if we don't see it. It helps engineers build bridges, doctors model the spread of diseases, and programmers make apps smarter. Today, we'll talk about 3 key parts of calculus. Differential calculus, which looks at how things change instantly. Differential equations, which help us describe changing systems over time. And integral calculus, which helps us measure and add things up, like area under a curve or total distance traveled. Whether you're solving real-world problems or writing code, calculus gives us the tools to understand, predict, and control the world around us.
Wow.
Why do roller coasters make your heart race? Calculus has the answer. Calculus is like a superpower for math. Am I the only one that didn't know why coffee cools down so fast? Well, let's find out. So, you've got a steamy cup of coffee. Yum. But have you noticed it cools down pretty quickly? That's Newton's law of cooling at work. Basically, the hotter your coffee is compared to the room, the faster it loses heat. Imagine your coffee is a hot superstar, and the room is like a chill fan. The bigger the temperature difference, the more your coffee wants to cool down to match the room. It's like a dance between hot and cool. So next time you're sipping that brew, remember, even coffee follows the laws of physics. Newton said so. Stay curious, science lovers. And don't forget to enjoy your coffee while it's hot. I bet you didn't know Newton had a law for cooling coffee. Let's break it down. So you pour yourself a hot cup of coffee. But before you know it, it's cooled down. What's happening here? Enter Newton's law of cooling. Basically, it says the rate at which your coffee cools is proportional to the difference between its temperature and the room temperature. In simpler terms, the hotter your coffee, the faster it cools down. Imagine this. Your coffee's temperature is T. The room's temperature is TNV. The difference between them is key. The bigger the gap, the quicker your coffee loses heat. There's a constant K that tweaks the speed based on the coffee's properties. And that's Newton's law of cooling in action. So next time you sip that cooling coffee, thank Newton for the science behind it. Cool, right?
This is why you need exponential distribution in your life. Ever waited in line and wondered how long it'll take? Let's break it down. Exponential distribution helps us model the time between events in a Poisson process.
Wow.
Think of it like this. If you're waiting for a bus and buses arrive randomly, exponential distribution can tell you the average waiting time. Mathematically, it uses a probability density function, PDF. Fx equals sign lambda e all x. Here, x is the time variable and lambda is the rate at which events happen. So, if buses come often, lambda is high. And your wait time is shorter. Simple, right? Exponential distribution helps us predict and plan for random events. Next time you're waiting, remember, math's got your back. Stay curious and see you next time.
What do rivers, air currents, and your morning coffee have in common? They all follow the rules of the Navier-Stokes equation. The Navier-Stokes equation is like the ultimate traffic rulebook for fluids, liquids, and gases. It tells us how fluids move, twist, and turn when forces like pressure, gravity, or friction act on them. Here's the gist. Imagine water flowing through a pipe. The equation considers factors like the fluid's density, its stickiness called viscosity, and even how fast it's moving. Wow. It's a lot like solving a puzzle where every piece is connected by calculus. At its core, the equation balances forces in a fluid to predict its motion over time. It's why engineers can design better airplane wings, improve pipelines, and even predict weather patterns. So next time you see water flowing, remember, it's all about math, physics, and the magic of the Navier-Stokes equation. Pretty cool, right?
If you're into science or just love plucking guitar strings, you'll love this harmonic motion explained with clay. All right, harmonic motion. It's just a fancy term for back and forth movement. Think of a swing at the park, a bouncing spring, or that guitar string you just plucked. It's all about balance. Here's the sciencey part. When you pluck a string, it vibrates because forces pull it back to its resting spot. That's harmonic motion.
Wow.
And guess what? Mathematicians have it all figured out with one slick equation, dd plus dt2 plus kx equals sign 0. Translation? The mass, m, and the spring constant, K, control how the object swings back and forth. So next time you strum a guitar or bounce a spring, remember, it's not just motion, it's harmonic motion. And at the heart of it all, differential equations, the backbone of calculus, helping us understand the universe's rhythms. Science and math together, now that's cool.
Calculus isn't just math, it's a key to unlocking the mysteries of our world and shaping the future. From the flow of rivers to the stars above, calculus is the poetry of the universe. It's not just for classrooms, it's for dreamers, innovators, and explorers. So, the next time you sip your coffee or gaze at the night sky, remember this: calculus connects us to the very fabric of reality. It's not just equations, it's the rhythm of nature, the bridge to innovation, and the language of possibility. Calculus empowers us to break down the impossible and build the extraordinary. It's the ultimate tool for shaping tomorrow. So go ahead, embrace the challenge, explore the unknown, and let calculus guide you to greatness. Because with calculus, the universe isn't just a mystery, it's your playground. And the possibilities? They're infinite.